In this video, I want to start talking about k-nearest neighbors and then go towards plotting the graph of the performance of k-nearest neighbors versus the k in KNN. So first of all, what's k-nearest neighbors? Well, imagine that you have a data set that's like that. What does that mean? Well, it means that this point, for example, it has coordinates that are x1 and x2. So this point is x1, x2, and now the label that's associated with this point is green. So in the training set, it looks like this. It looks like x1, x2, and green. This guy is a different x1, different x2, also green. This one is a different x1, different x2, and pink. So that's the training set. Now, what are we trying to do here? We're trying to say, we have a training set. Let's say that now we have a test point. And maybe the test point is somewhere over here. All right? This test point also has coordinates. So it has the coordinates, let's say, t1 and t2. So what do we do in order to decide whether this point should be green or whether it should be pink? Well, k-nearest neighbors says, well, compute the distance between this test point and all the points in the training set. Then select the k-nearest neighbors, meaning the k points that are closest to the new test point, and do a vote among them, among their labels. Whichever is the majority, that's going to be the label of this guy. So for this guy specifically, what is it going to be? Well, if it's one nearest neighbor, then its nearest neighbor, in the sense that the distance between it and the point is as small as possible, is this guy. And it's green. So one nearest neighbor would output green. Three nearest neighbors, those are the three nearest neighbors, would output green as well. If you tried 6 nearest neighbors, this would be those guys, so it would be 2 pink and 4 green, so it would still say green. But that's for this particular test point. What about this test point? For this test point, if you do 1 nearest neighbors, it'll say pink because this guy is the closest. If you do 2 nearest neighbors, it'll say pink because both of those guys are the 2 nearest neighbors and they're both pink. On the other hand, imagine doing 5 nearest neighbors. The neighborhood here of the 5 nearest neighbors is like that, and if you do a vote, green wins. So for this test point, for 5 nearest neighbors, you would output green, but for 1 nearest neighbors, you would output pink. Which one is the right one for this guy? Well, you can't really tell without more data, because it might be that there is a genuine island of pink points over here. It might be that those guys are just here by accident. But the fact that they're both in here together, close by, kind of suggests that, yes, there is a genuine island of pink points over here, so it might be reasonable to say that this guy is pink. But really, you'd need more data. Okay? If this point was not here, so if it weren't here, if it was like this, then I would say, well, just because there is a pink point here doesn't really mean anything. It's probably noise. So just looking at it, although this is obviously informal, you'd say, okay, probably 1 nearest neighbor is not the best. Probably you should just do 3 nearest neighbors, in which case, in general, of course, and for this particular point, you do 3 nearest neighbors, and it comes out green. Of course, like we said, the way to actually check is to do cross-validation. How do you do cross-validation? You say, okay, fix a k, and we're doing k nearest neighbors for this particular k. And in that case, what you do is you'd say, okay, so I'll take out this point of the training set, and I'll try to classify it using k nearest neighbors, and I'll see if I'm right. Then I'll take out this point, it's not in the training set anymore, and I'll try to classify that using k nearest neighbors, I'll see if I'm right, and so on. And then you select the k for which this procedure gives as many correct answers as possible. So this would be cross-validation in order to figure out which k is the best.